The synchronization part is all about ensuring the synchronization topic. What is this synchronization topic? The whole idea now is not to forget that we have, regarding the circuit breaker, for the circuit breaker now, you have here, for example, let's say a bus bar, then a breaker, and then what is this in? Okay, great. So here you have a voltage transformer here. Okay, and you also have a voltage transformer here located on the bus bar side. All right, so what are the conditions for synchronization? The idea is quite simple. For this breaker to close here, this side has a specific waveform, and this side has a specific waveform as well. The conditions for synchronization can be divided into two parts, something we refer to as manual closing, referred to as manual closing, and the other thing is called Synchrocheck. All right? The idea is quite simple. As we say, for you to close the breaker now, there is voltage before it and voltage after it. Now, for you to close this breaker on 2 voltages, certain conditions must be met. These conditions are divided into 2 things. One we call manual closing, and the other we call Synchrocheck. For manual closing, there are 2 important conditions, which we refer to as live line or dead bus, and the second condition we call deadline, live bus. So we refer to it as live line, dead bus, or we call it deadline live bus. All right? So how does this work? The matter is quite simple and goes as follows. Right now, it tells you that the bus could be dead and the line could be live, or the line could be dead and the bus could be live. In this case, one side has power and the other side does not. Of course, in this case, if you close it, you won't have any problems at all. So how do you confirm this? Here, we confirm from inside, or any device specifically used for double checking. That's it. Or any device specifically used for confirming the other, like the magnitude of the voltage. All right, so you have a setting here and a setting there. This setting is the dead condition, and this setting is the live condition. For example, I might say that the live condition has a certain quality and the dead condition has another. Therefore, the 2 voltages that will be read, one from the bus and the other from the line, one of them must be present at this point and the other must be present at point A at this point. All right, engineer, great. Okay, this is regarding something referred to as not necessarily closing. It means that you are on one side and the other side is fine and the other side is okay, so there's no problem. You don't have anything that needs someone to check on it. All right, that's good. Now, let's see where the problem is if I'm talking about Synchrocheck. Synchrocheck, usually, engineer, involves both sides being added. What we learned in college was that you must have the same voltage, the same angle, and the same frequency. But in reality, the idea here is what? It will be that you have the delta V, which is the voltage difference between the line voltage and the bus voltage. All right, in terms of magnitude, I'm talking about it as a magnitude or modulus, meaning as a positive value. Whether this is greater than that or this is less than that, it must be less than or equal to a certain setting. All right. And you must have the delta phi, which is the phase angle difference between this and that, also be less than or equal to a certain setting. All right. Additionally, you have the delta F, which is the frequency, and it must also be less than or equal to a certain setting. Moreover, they both must have the same phase sequence. All right, guys, that's good. So according to the ratio of the VT, for example, if my VT is 115 kilovolts, it converts them to 115 volts. So I'm talking about the single phase voltages. Of course, this is phase to phase. So the single phase voltage would be 66 point something, 0.4 volts. Then I say, well, the delta V should not exceed 5 volts on the secondary side, of course. Delta phi should not exceed 10 degrees. And delta frequency should not exceed a point. And both should be the same. What does this mean? What are we talking about here? Of course, guys, these are the synchronization conditions I'm talking about. So if you go back here again, this is our drawing. you'll find that if I choose the emergency mode, I'll follow one path, and if I choose the remote mode, I'll follow another path. All right, the local or remote path passes here through what? Through a box here, a dashed one, placed inside a black square, but labeled as PCU. So here, this is something coming from the PCU. Where is it located? It's inside the same cell of mine, which is why you won't find it dashed like this one. Instead, you'll find it black, like a black color. So you just understand that it is inside the LCC, but on the door of the LCC, oh, all right. All right, what's up with this contact? Well, when you choose the local mode and come here and give a close command from the PCU, the open contact here closes, passes through here, goes down here, and comes like this. Since you've chosen the local mode, this is closed. It comes here as the PCU itself gives the close command and checks for synchronization. If there wasn't synchronization, whether it was a manual closing condition or synchronization, it would close its contact. Whether it was a losing condition or a synchronized condition, it would close its contact. Okay, if I am in the emergency mode, if you are in the emergency mode, you will press select and press close. When you press select and close, what happens? The positive comes here, passes through, and you find yourself having chosen the emergency mode, so this is also closed. Here you have something called sync auto and something called sync manual. We choose something called sync manual. What is this sync manual, dear engineer? The sync manual is a selector switch. You have auto and manual, but we are only using manual. So you set the selector to the manual position. You have something called the trolley. The trolley, dear engineer, is a device available at your station. A trolley is like a cart that has 3 meters, like the synchroscope. The synchroscope has 3 meters, one for the angle difference, one for the frequency difference, and one for the voltage difference. So with this trolley, it is movable, meaning it's portable, and you can transfer it to any cells. It comes with a plug that you install in your cells to connect the voltage of the A bus and the voltage of the Y. You look at the 3 meters to ensure the voltage difference and the angle difference. Inside, there is a push button. Inside, there is a push button that you press to close. There will be an operator standing at the cell, pressing the selector to close, and you are standing to check the synchronization. As soon as you see synchronization with your eyes, you are the one who presses close here. So whether the synchronization is achieved through the PCU in case you choose local or remote, or it is achieved through the trolley, but it is up to you to see it yourself. Someone is asking, emergency refers to storing another station, engineer. Emergency means you have several modes in emergency. I told you close from the cell itself by pressing select close local, which is the place of the old control room. Remote means from the substation automation system or SCADA. So here, the word emergency engineer means that naturally you should always close from SCADA, from SAS, from remote locations. But in some emergency cases, communication might not have fallen. You are not able to see the station. So you can come to the station yourself. Through the cells themselves, you can give some close and open commands to the tasks you have or the components you have, like the disconnector switch, the air switch, the breaker, and so on. This is called an emergency, not an emergency in the sense that you are in a critical situation and it brings electricity from the next station. No, don't let your mind go down that path at all. I'm talking about an emergency in the sense that you don't know how to close from the PCU, you don't know how to close from the SCADA, you don't know how to close the remote. So you come to the station and use the station itself, because now all the stations have become automated. Ideally, you should close through the computer screens available in the substation automation system or in the SCADA system, okay? The difference between it and the local is that the local closure is done through the PCU itself. In the past, this closure was done through the control room, but now it's done through the PCU located in the same cell. This means that you are also present in front of the cell itself. So currently, there is no difference because the PCU is in the same cell. There is no difference. But the only joy is that the PCU will handle the synchronization process for more or less. However, if you are setting up the emergency, you will just bring a trolley and look at its synchroscope. Sometimes you have a synchroscope available inside each LCC. Of course, it's just a mode of operation, nothing more, nothing less. But if you're talking to me about the PCU, as a PCU, you need to choose the local mode, which means you will shut it down via the PCU. This means you must be present at the station and standing in front of your cell, of course. All right, whether it's this or that, you come here to ensure that K120A or K120B are closed so that in the end, you reach the same type. So, what's up with K120A and 120B? They are present here in the same panel. So, what do K120A and 120B depend on? There's a long story here with K120A and K120B.